All right, this is an interesting question. Determine if the quadrilateral can be a parallelogram and explain. So two opposite angles are right angles, but the quadrilateral is not a rectangle, right? So we have a quadrilateral, and let's just draw just any kind of quadrilateral, and we know that two opposite angles are right angles, but the quadrilateral is not a rectangle. So if it were a parallelogram, that means consecutive angles would be supplementary, right? And if one was 90, that means the other one would have to be 90, right? So for this to be a parallelogram, this would be 90 and this would be 90, right? For the same reason, and it would have to be a rectangle. And so that means this can't be a parallelogram. It'd have to be something else, right? So in other words, like these would not be congruent. They would just be some random value. Okay. All right. So this would say this. So this cannot be a parallelogram because if it were, it would have to be a rectangle, right? By these criteria. All right. So 37, 38, we're finding the measures of the numbered angles in each rhombus. So we know it's a rhombus, and so angle 1 would have to be 57, right? Because the diagonal bisects that angle there. Angle 2 would also have to be 57, right? Because these are alternate interior angles. We know these are parallel and these are parallel. So we have alternate interior angles. So angle 2 would be 57. And then angle 3, we can, if angle 1 and angle 2 are 57, then we can do 180 minus the sum, or minus 2 times 57, and get that right. So we can do 180 minus 57 minus 57, and we get 66. So angle 3 is 66 degrees. Okay. All right. 38. So here we have another rhombus. We know that diagonals of a rhombus are perpendicular. So angle 1 and angle 3 and are equal to 90 degrees. And I should put measures of for all these, right? Okay. All right. And then angle 2, well, if this is 90 and this is 32, remember these are complementary, so I can just do 90 minus 32, or I could do 180 minus 90 minus 32. Either way, it'd be the same, right? And it'd be 90 minus 32, and 90 minus 32 is 58. So that's what angle 2 is, measure of angle 2, 58. All right, and the next one, we're trying to find the value of the variables and find the length of the sides, okay? I think this should say then find the length of the sides. So number 42, we're given that these are congruent, right? So we can set 4y plus 6 equal to 7y minus 3. And so we can subtract 4y from both sides. And we can add 3 to both sides. And we get 9 equals 3y. Then we can divide by 3. So we get y equals 3. All right. And then we can plug in that value here and in these spots to find all those sides, right? So here, 5 times 3 plus 1.4 is 16.4, right? And then let's see, let's do it over here. So 4 times 3 plus 6, so that's 12 plus 6, 18. So this must also be 18. Okay, so that's that one. And then number 43, these are congruent and these are congruent, right? So we can actually make a system of equations. We can say 3m equals n and 7m minus 14 equals n plus 6. So we can take this value for n and plug it in for that n. So 7m minus 14 equals 3m plus 6. And so then we're in business from there. We can just subtract 3m from both sides. We can add 14 to both sides. And we get 4m equals 20 divided by 4. And we get m equals 5. Okay, and so if m equals 5, we can find n by just doing 3 times 5, which is 15. So those are our two variables. And then to find the sides, we can just plug them in, right? So n plus 6, that's going to be 21. So that will also be 21. If you want to double check your work, you can do 7 times 5, which is 35 minus 14, and that gives you 21, so that confirms that. And then we know that n is 15, and that makes this also 15.